Okay, ladies and gents, so this is page 463 on tree diagrams. The first one that we did, number 2, asked us to make a tree diagram for rolling a dice and tossing a coin, and then they asked for a bunch of probabilities. So you can see we have two events here, rolling the dice and tossing the coin, and then the outcome of each. So under dice, you just roll, you roll all the possibilities, so 1 to 6. And then same for the coin for each of those. So like if we had a 1 on the dice, what could happen when we flip the coin? Well, heads or tails. Same for, if we got 2 for the dice, heads or tails, all the way down. And then you write down the outcome of each. So starting here, 1 heads, 1 tails, 2 heads, 2 tails. Okay? So then it asked us probability of getting a head and a 4, so favorable over total. There's only one head and a 4 right there. Out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 events. So that's our probability, 1 over 12. B asked us for any number less than 3, and that was the only criteria. So that would be 1, 2, 3, 4 of them, because we only get to use the numbers 1 and 2. So it'd be 4 over 12 reduced to lowest terms, like in our fractions unit, 1 over 3. Okay. For C, it asked for a tail and any prime number. So the prime numbers that we're getting on dice are 2, 3, and 5. So we can use all the events from 2, 3, and 5 that have a tail. So that would be 3 of them out of 12 reduced down to 1/4. And then the probability of a number that's not a 5. So these are the only ones we don't get to use, so we can use the rest. So we can use 10 out of the 12, which reduces down to 5/6. Okay, number 5 said you have dice and a deck of cards, and they said they wanted you to try doing this experiment 10 times. So roll a dice and pull a card randomly from the deck and record what suit you get, clubs, diamonds, hearts, or spades. And then you're supposed to combine it with 9 classmates so that you get a total of 100 trials. Obviously, you don't have 9 classmates, so I don't know if you did the experiment or not. What the idea here is that, if you only did it 10 times, the likelihood of you getting the answers anywhere close to the theoretical probability that we're going to talk about in a moment are very low. Okay, like even flipping a coin, you could flip a coin 5 times and it could come up heads 5 times. If you get up to like 100 trials of something, that experimental probability is going to start getting closer to the theoretical probability. So, and that's actually what the next lesson's all about. So anyways, if you did that, cool. If not, here's the tree diagram. Okay, so again, 2 events, the dice and the suit. So you see 1, clubs, diamonds, hearts, spades, 2, clubs, diamonds, hearts, spades, and then the outcomes for each. Okay, so the first one asks for a probability of a heads and a 4. Well, there's only one of those, which would be heads and 4 right here, that guy. Okay, and that's the only one out of all 24 of them. Number 2 said heads or diamonds and a 2. Well, so diamonds, or sorry, not heads and diamonds. Diamonds are hearts and a 2. So those are 2 favorable outcomes out of the total of 24. So reduce that down to lowest terms, 1 out of 12. So the next said a probability of a diamonds and a hearts and a 1, 3, or 5. So for 1, 3, and 5, we get diamonds and hearts being active. So that's giving us a total of 6 over 24, which reduces down to 1/4. Okay. For question F in this one, it says, compare the theoretical and experimental probabilities that you got. So if you only did this 10 times, the chances of you getting these answers are really low. But then it asks, what do you think would happen if you carried out this experiment 1,000 times? If we did it 1,000 times, we would be getting very close to these answers. The more trials you have, the closer you get to theoretical probability. Okay, number 6 said, neither Andrew nor David likes to set the table for dinner. They toss a coin to decide who will set the table. David always picks tails, and they want us to find the probability that David's going to set the table 3 days in a row. Okay, so we built a tree diagram. So there's 3 events happening: flip 1, flip 2, and flip 3. And on each flip, you can get heads or tails. So flip 1, heads or tails. On flip 2, assuming we got heads, we could do heads or tails. If we got tails, heads or tails. Flip 3, off of this one, we could do heads or tails, so on and so forth. And then listing our outcomes: heads, 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 tails, heads, tails, heads, heads, tails, tails. Okay, so hopefully you get the idea. So it said, he always picks tails, so probability that he's going to set the table 3 days in a row. Well, there's only one favorable outcome where we have all of the tails out of a total of 8, so it's 1 out of 8. Okay, so that's it for now. Bye.